All right, you guys ready? You ready? You ready? Anybody not found this page? Yes, I'm recording this one because I forgot to record first hour.
Last time you recorded first hour, all I could hear was Nicholas and Brendan trying to make small talk and you were like walking away. It was hilarious. You tried to watch one and now she heard one.
Was I loud enough though for the part that I was? Okay. It's just good to know because I don't sit there and watch my videos over and over again. I also don't clip out parts like this because I don't have time. Huh.
Right now?
Is the percent error calculation theoretical minus theoretical minus theoretical?
No, it doesn't matter because it's absolute value.
Oh yeah.
Okay, but then theoretical goes on bottom.
Yeah.
Okay. All right, here we go. Percent yield. So when I make chocolate chip cookies, my recipe tells me that I should end up with 64 cookies. And I usually do, if my husband isn't home. If he's home, he always eats the raw cookie dough. And so I don't get the yield that I am anticipating based on my recipe card. So my recipe card is my theoretical yield. My actual yield is how many cookies I end up with. Okay. And then I can do a percent yield based on that. The same thing happens in terms of chemical reactions. You typically expect to get so much stuff made, but oftentimes because of various reasons, you don't end up with that much. Okay. So what you end up with is called your actual yield. And I tell people to think of this as your recipe card. Okay? It even kind of looks like a recipe card, doesn't it? So that's going to tell you how much you should be making. And then somewhere in the problem, they're going to tell you how much you actually made. Okay? And then we perform this to be able to figure out what our percent yield is. The higher percent yield you get, the better, your reaction ran. Does that make sense? So you're hoping for 64 cookies, but it doesn't always happen. Maybe you drop some on the floor. Maybe your husband scoops out, several and eats them ahead of time. It is what it is. All right. So let's run through a few of these samples. We have chlorobenzene is being produced here. It is going to be produced when benzene is reacting with chlorine. And that's going to produce, it says here, chlorobenzene. And you would never, ever in here be expected to know what that formula is. We would always give you that. And HCl. Okay, so they told us it's forming chlorobenzene and HCl. So that's where I got the HCl from. I got it from the problem. Okay, good? Everybody up with me so far? All right. Need to make sure that my equation's balanced. Is my equation balanced?
Is it H6 or H5?
Oh, what did I do? Yep, you're right. You're right. You're right. When you're right, you're right. It's a 5 there. Lippy goofed. That should be a 5. All right. Now is my equation balanced? Here? No, that's a 6 and a 6. So I think I'm okay now. And I'm balanced, yes? Okay. All right. So we're going to go through here. They're telling us that we are starting, and that's off the screen here. I got to scoot over a little bit. We're starting with 36.8 grams of this guy. So I've got to take my 36.8 and convert that into moles because only moles in the holes. So I'm going to divide that by the molecular mass of this, which is 78. And that's going to give me my moles. 36.8 divided by 78. It's going to give me my moles here of my benzene. So 0.472. Alex, you know where I got that from? 78? Okay. All right, so 0.472. If I read through this, it tells me that I have excess chlorine. So this is going to be excess. And I haven't started with any of this. All right, now we're going to take this and we're going to go up through the cloud and we're going to divide by our coefficient. So this is pretty easy. So we're just taking this and we're dividing by 1. Then I don't have to check 2 different clouds because they already told me this was excess. So we're just going to use this to distribute. So minus 0.472, which leaves me with 0. Minus 0.472, which leaves me with excess. This is going to be plus because we're on the product side here. So plus 0.472. And that's 472. And then plus 0.472. Did I lose anybody along the way there? Anybody not know where any of those numbers came from? Everybody's cool with that? Okay. So now they're talking about the chlorobenzene. So I'm going to take this mole value. I'm going to divide by the molecular mass of this. So 72 plus 5 for my hydrogen plus my chlorine gives me 112.5. I got those values right off the masses on the periodic table. I added all of those up and that gave me 112.5. So that's going to give me my grams of C6H5Cl in theory. So this is how much I should have made if this reaction would have all gone correctly. Okay, so that, why did I do that again? I did that last hour. There we go. So 53.1 grams. So that's how much I should have made. Now, in reality, this is all we made. So I'm going to take that, divide by how much we should have made, times 100. Did I goof something?
Yeah, I got those.
I need to multiply here, not divide. I don't know why I keep writing divide down. Is that better? I even did it in my calculator wrong. I don't know what. I did that first hour too. I don't know what my problem is. I'm so sorry, guys. Yeah, good thing to ask, especially when I'm recording this. All right, good. Okay, so now you know where I got the 53.1. Now I'm going to divide this amount by how much I should have had times 100. And that's going to give me 73.1% yield. Good? It's not a great yield, but the answer's right, I think. Okay, does it make sense how you do those? That's the last thing in chapter 11 we have to learn. All right, let's do another one. We've got potassium chromate.
I was really excited.
And it's going to go with AgNO3. They're telling us that we're forming Ag2CrO4. Are we going to have anything else? That's all they mentioned. What's the problem with this? Yeah, and? What else is it missing? Okay, yeah. So what type of reaction is this? If you just look at your reactants and you don't look at this at all, what type of reaction would you say this is? Double replacement. They just didn't tell you what your other product was. They figured by now you should be able to figure that out. All right, I got to balance this. I got 2 potassium here. I need 2 over here. Now I've got 2 nitrates and 2 silvers, so I'm going to put a 2 there to get those to balance. All right, so now we're going to take our 500 grams of AgNO3. We're going to convert those, and I'm going to try to do this right this time. I'm going to convert those into moles of AgNO3. So I need a silver, I need a nitrogen, and I need 3 oxygens. So that's 169.9. So I'm going to take 500 divided by 169.9.
It's 0. It's 0.
Oh, did I got a scoochie. Oh, it's 0.5. That would make a little bit of a difference, huh? So 0.5 divided by 169.9. All right, there we go. Couple place value differences there. So 0.00294. Now, they didn't tell us about this guy. So if they don't tell us about him, what do we have to do? We just assume that it's an excess amount. And then we're not starting with any of this. All right. So at this point, this is going to go up and become my cloud. When I go up into the cloud, what do I have to do with this coefficient? Yes, I divide by the coefficient. So 0.0294 divided by 2 is 0.00. Oops, I need to switch over to this so you can see it better. 0.00147. Okay, then that becomes my new value that I'm going to multiply through. So I'm going to use that, multiply through the coefficients here as I go down. Multiply through the coefficients. As I go down and I multiply through the coefficients, my reactants I'm going to be subtracting from. My products I'm going to be adding because I'm making more of those, or I'm making them. Yay or nay? Good? Okay. All right. So I have figured out the moles now of silver chromate. I need to take these moles and I need to convert them into grams. So I'm going to take the 0.00147 grams. I'm going to multiply, I got it right this time, y'all, by the molar mass plus I need a chromium, which is 52, and I need 4 oxygens. Okay, so that's 331.8, and that's going to be grams per mole. This was moles, not grams. Good grief, I can't do anything right. This is moles. So my moles will cancel. It's going to leave me with grams. At least I got the thing written down right this time. All right, so that gives me 0.488 grams of Ag2CrO4. So that is the answer to A right here. So this is my first answer. Then they're asking me what the percent yield is. Well, if I have 0.455, but I was supposed to have 0.488, I'm going to divide those, multiply by 100, and I get 93.2%. Yay or nay? Is it making sense? Want to do one more? Alex?
Where is the 0.455?
Right here. Good? What else? Anything else you want me to? Okay, let's do another one. It's a little sloppy on here, doesn't it? All right, this is a single replacement reaction. We've got copper. We have silver nitrate. Our copper is going to go in with the silver nitrate. And our silver is going to go sit on the bench. We've got 20 grams of copper. So I'm going to take my 20. I'm going to divide by 63.5, which is the molar mass for copper. And that's going to give me my moles of copper. This, they didn't tell me anything about. So we're going to assume excess, and we didn't start with any of the products. Good? All right. So now my cloud is going to have what in it? Right, 0.315, because I'm going to take this. Oh, wait a minute. I have to balance this. Hold on, y'all. 2 and 2. Okay. That's not going to change my cloud, luckily. Okay, so 0.315, my cloud. So I'm going to bring that down. What's this going to be minus? Minus how much here? 0.630. Okay. All right. So we have made this much silver. That's in moles. What do I need to do with that mole amount? Right, so I got to find the mass on the periodic table for silver. So times 107.9 equals that's 68.0. All right, so that's how many grams of silver I should have made. In reality, I only made 60 grams. Circle that very well. Do you see the 60 here? This is how much we actually made. So we're going to take 60 divided by 68 times 100, and that equals 88.2. And that's my percent yield. Easy enough? All right, you want to do another one? try to do one more. They've given us our balanced equation. All right, here is my aluminum hydroxide. Apparently, we're going to have an excess amount of this. So see if you can figure out, starting with this much aluminum hydroxide, see if you can figure out what your percent yield should be. Go. I'll do mine. I'm going to try to do it behind you. Yeah. Yeah, take a pass. Write your name on the board. How many spots are left on that? Is it getting filled up? Oh, pull it off then and throw it on the counter over there, and I'll put it up in a little bit. Thank you. Figured it was getting about time that it was filling up. .179. How's she doing? Did you get this, Kendall? Did you get 0.179? Huh? Ah. There we go. All right, how'd you do? Good. Jariah, you okay?
Yeah.
Hmm? Alex?
I got 0.9.
0.9?
Oh, I didn't times it by
You didn't
100.
times it by 100? Okay. That's an easy fix.
Other than that,
Aiden, you good?
He's already doing the homework.
he's been doing it.
Good for him.
He knew what we were doing before we
Yeah.
even did it.
That doesn't surprise me at all.
Go to APA. There you go. What'd you take? Physics.
All right. Want to do another one? No? Do your homework then. Okay. All right, we'll stop there then.